Welcome. So in this video, we'll be answering this question before us. It says for the function g of x is equal to this, find the implied domain of the function. Well, the first thing that we're going to realize is that this is a truncus. So let's just give it a bit of a sketch. Draw axes. Because I've got x plus 2, that means it's shifted 2 to the left. So let me just grab another color. And because I've got minus 4, it means it's shifted 4 down. So if I can just put in my asymptotes to begin with, I know I'm going to have an asymptote here at x is equal to negative 2. And I'm going to have another asymptote here at y is equal to minus 4. So these are just rough lines, just a little rough graph, just so I can have a visual of what's going on. It's going to look something like this. So now when I'm asked to answer this, and it's asking for me to give the implied domain, my domain is simply going to be, all real numbers excluding negative 2. Because as you can see here, all my x values exist except for when x is equal to negative 2. And just like that, I've answered my first question. Okay, next, find the coordinates of any y-intercept. So remember, to find the y-int, you let x equal 0. So I'm going to get y is equal to 1 over 0 plus 2 squared minus 4. Y is equal to 1 over 4 minus 4. Now, once I'm here, I'm going to have to write this so they have common denominators. So this is going to become 16 on 4. And that means my answer is going to be y is equal to negative 15 on 4. Now here's the all-important part of this question. Many of us will just leave our answer as this. But you see how it's worth 1 mark? That means that you would get no marks for this unless you put it in coordinates, because it says find the coordinates of the y-intercept. So you need to make sure that you give them what they want. So the answer to this is 0, negative 15 on 4. If you did not write that, you'd get no marks for this, because that's what the final answer has to be. So let's just put a box around that, like so. Perfect. Next, find the coordinates of any x-intercept. So let's get our pen out again. So to find our x-intercept, we let y equal 0. Let's zoom in here, because this might take some time. So we're going to go y is equal to, we're letting y equal 0. 0 is equal to 1 over x plus 2 squared minus 4. Now I'm just going to rearrange to solve it for x. So I'm going to plus 4 to both sides. Then I'm going to move this up. So I'm going to get 4x plus 2 squared equals 1. Next, I think I'll expand this out. So I'm going to get 4. This is x squared plus 4x plus 4 is equal to 1. There's a couple different things I could do here. Let's divide both sides by 4. So I'll get x squared plus 4x plus 4 is equal to 1 on 4. And then I would subtract 1 over 4 from both sides. So I'm going to get x squared plus 4x. Now, this right here is the same as 16 on 4 minus 1 on 4 is equal to 0. So it's going to be x squared plus 4x plus 15 on 4 is equal to 0. Now, once I'm here, it's pretty clear that I'm going to have to use my quadratic formula to do this. So I'm going to go x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, which means x is going to be equal to, my b is 4, so it's going to be negative 4 plus or minus the square root, then 4 squared minus 4, then a is 1, and this isn't going to be big enough. It's going to have to be 15 on 4, and all of this is square rooted, over 2 to the 1, 2 times 1, x is going to be equal to negative 4 plus or minus the square root of 4 squared minus, let's write that as 16. 16 minus. Now, do you see here how I have 4 times 1 was just 4, and then I've got a 4 in the denominator here, so these 4s are just going to go away with each other, and I'm going to be left with just 15 here over 2. X is equal to negative 4 plus or minus the square root of 16 minus 15 is 1 over 2. The square root of 1 is just 1, So my answer is going to be x is equal to negative 4 plus or minus 1 over 2, which means x is going to be equal to negative 4 plus 1 over 2 and negative 4 minus 1 over 2. So that means my final answer is going to be, remember, I have to write my answer in coordinates. It's going to be, therefore, negative 4 plus 1 is negative 3. So it's going to be negative 3 on 2, 0. And then my other one, negative 4 minus 1, would be negative 5 on 2, 0. So those would be my answer. So as you can see, this one took some time, and I might even explore another way of answering this. Of course, you would only have to do one way, but let's just talk about another way of answering this. And it really comes down to this spot right here. So if I can just take this for a second and just show you another way of approaching it from this point. So let's copy this. Let's come over here. Let's paste it there. So there's our answer. This is just now doing a bit of an exploration. So please don't do it twice. In the test or exam, just do it one way. So here's just an alternative way of doing this. Alternative. So an alternative is that once you get to this spot right here, remember what we did previously is we divided both sides by 4. But if instead you multiplied out by 4 here, so you get 4x squared plus 16x plus 16 equals 1, then you minus 1 from both sides, you would end up with this. Now we could factorize this. So if we were to factorize this, and let me just keep working down the page. If I was to factorize this, I would say 4 times 15 is 60. So remember, that's what you do. You go this times this is 60, and you need two numbers that multiply together to get 60, and that plus together to get 16. This one's pretty easy. It's just going to be 6 and 10. 6 times 10 is 60. 6 plus 10 is 16. And then from that, what you can do is you can break up this 16 now into, and let me just keep working down the page, 4x squared plus 6x plus 10x plus 15 is equal to 0. And now what you can do is you can factorize, or pull out a factor there and pull out a factor there. So here I can pull out 2x and I'll be left with 2x plus 3. Here I can pull out 5 and I'll be left with 2x plus 3. And hopefully you can see here that I've got 2x plus 3 here, 2x plus 3 here. So now I can pull that out as a factor. And what I'm left with is 2x plus 5. Now using my null factor law, I can set this equal to 0, so 2x plus 3 is equal to 0, and I can set this equal to 0, 2x plus 5 is equal to 0, and I would end up with x is equal to negative 3 on 2. That's a funny looking 2. And here I would be x is equal to negative 5 on 2. And hopefully you can see that what we found here, so this negative 3 on 2 and negative 5 on 2 is what we found here, negative 3 on 2, negative 5 on 2. So it's kind of pick your poison, which one you like better. But both of those are acceptable ways of going about this, and it's just good that we do a bit of exploration. But remember, in a test or exam, you wouldn't do it both ways. You just figure out what you're after, and you do it that way. Okay, let's keep on going. The next is to state the equations of the asymptote. Well, we did this before. We did this at the beginning. So remember, we looked at this, and we said x is going to be equal to negative 2, and y is going to be equal to negative 4. So it's going to be x is equal to negative 2. Y is equal to negative 4, x is equal to negative 2. Yep. Then we have to figure out what the range of this thing is going to be. So again, this is why it's useful to draw ourselves a little sketch. The range is simply all the y values. So it's going to be starting at negative 4, but not including it all the way to infinity. So I would come here now, and I would go negative 4 to infinity. That's my range. My range is equal to negative 4 to infinity, not including that negative 4. And remember, you're not including it because it's an asymptote at negative 4. And at negative 4, it doesn't actually exist. So it's from negative 4 to infinity is your answer. Perfect. Hopefully you found this useful in getting your answers. And yeah, I'll see you in the next one.